Hello, and welcome to Share Science. Summer brings with it lots of opportunities to spend time outside, which is a great time to play with bubbles. We use soap every day for washing up lots of things, but do you know how it works? Today, we are going to learn how soap does its thing and how it makes bubble time so much fun. Our experiments today are going to center around liquid dish soap and some fun ways you can play with it. If you want to follow along, you're going to need a few things. Start with a bottle of dish soap and several shallow plates or trays and enough water to fill the plates. For our first experiment, we need a pepper shaker. For our next experiment, we'll use some plain paper and scissors to cut it to shape. And for our final experiment, we'll need some glycerin, a bubble wand, and soft wool gloves. Alternatively, you can use sugar and any soft fabric. Even long sleeves can work. Once we have our equipment, we are going to learn 3 key things to better understand the power of soap. We're going to learn how soap works to break surface tension in water and wash dirt away. We're also going to talk about why all those bubbles form when we're cleaning. And finally, we're going to show you a way you can keep the bubble fun going by adding sugars to our soap mix. Here's our plan. First, we're going to fill a plate or tray with water and then sprinkle pepper to cover the surface. Then dip your finger in soap and try to touch the pepper and see what happens. Next, we'll cut out a small paper boat shaped with a cutout at one end. Drop some soap into the cutout and watch the boat go. Finally, we're going to make some super bouncy bubbles by adding glycerin or sugar to our mix. For every tablespoon of soap, add 2 tablespoons of glycerin or sugar and 6 tablespoons of water. Blow a few bubbles and explore how strong they can be. Here's a demonstration of the pepper experiment. We start with a clean plate and add enough water to cover the surface, followed by a sprinkle of pepper. Notice how the pepper spreads out. That's because of water's high surface tension, which we'll discuss later. Now, when we try to dip our finger in the water, not much happens. However, when we add a small amount of soap and repeat the experiment, we see the pepper scatter. Let's watch that again. Let's take some time to walk through how that works. Water has a lot of unique properties, one of which is high surface tension. This means the water molecules on the surface are so attracted to one another, they're hard to break apart and will actively push anything on the surface away. That is why the pepper spreads out when we first sprinkle it on the surface. Now, when we add soap to the surface, everything changes, since soap molecules have a really low surface tension and love to spread out. Soap's low surface tension has a lot to do with its structure. Each molecule of soap has one end that's polar and another end that's nonpolar. When we say something is polar, that just means it's charged and is attracted to other charged things, like water, due to its hydrogen bonding. The other end is nonpolar and is attracted to nonpolar things, like dirt or oil. If you want to learn more about hydrogen bonding, we've added a link to one of our other videos that goes into just this topic. When we add soap to the surface, the pepper attracts the nonpolar ends of the soap molecules, which surround each pepper, and the other soap molecules spread across the surface, pushing each of the trapped pepper particles towards the edge. This trick is actually a good way to visualize how soap works in general. Soap works to surround each particle of dirt or oil and then get whisked away in small particles. But let's see how it does with something bigger, like a boat. For our next experiment, we're going to make a small paper boat that will ride the surface, pushed with the power of soap. We start by cutting out our boat from a sheet of plain paper with a small circular cutout, which is where our soap will go. Using your finger or a Q-tip, take a small amount of soap, launch your boat, then apply it to watch it go. Once you get the hang of it, you can also try different boat shapes to see how well they work. Let's think about how our boat propulsion works. The soap molecules still want to spread across the water like in the pepper experiment, but in this case we have designed our boat so it can ride the wave. When the soap molecules start to spread, they push against the boat and really make it move. Now, since this propulsion system uses the low surface tension of soap to work, our boat will only go when there's space for our soap to spread out. See how many times you can keep adding soap before our boat conks out. Now that we know how soap works, we can explore another fun aspect of washing up: bubbles. When soap makes a continuous layer on the water surface and we introduce air by blowing or shaking things up, we can trap that air and make bubbles. While bubbles are a lot of fun, the fun only lasts as long as the bubbles do. So let's look at a way we can make the fun last longer by making super bouncy bubbles. We start with a standard mix for bubble solution, which typically is 1 tablespoon of solution to 6 tablespoons, or 1/3 of a cup, of water. To make the bubbles stronger, we can add 2 tablespoons of sugar or glycerin and mix until fully dissolved. You can also use hot water to help things along. With this mix, you should see your bubbles are a lot stronger, and you can even bounce the bubbles on soft fabrics, like wool gloves or a shirt sleeve. Try it out for yourself. Let's take a look at how this works. In a normal bubble, the soap molecules form a continuous ring around a thin layer of water on both the top and bottom, which keeps the water from evaporating and the bubble intact. Over time, however, water molecules find their way through and the bubble pops. When we add a sugar to the mix, the sugar molecules can help bridge the gaps that form between the soap molecules and keep the bubble together, even against the force when you try to squish it. To summarize, today we learned how soap helps us clean things by having one end that sticks to dirt and oil and another that's attracted to water. We can see just how much surface tension water has by how fast things move when we add a small amount of soap to the surface. Finally, we learned how to use that surface tension to make bubbles, and even how to make super strong bubbles by adding sugar to our solution. We hope you liked today's video. Please like and subscribe to get more content just like this.